With part three. So a very complex problem, and again, it breaks down really to just making sure that you're drawing the right diagram, and making sure the pieces you draw in a diagram fit the actual narrative, fit the story. Now, if you're not doing that, you're probably going to draw your diagram wrong, and the whole thing, well, it's going to be very frustrating. So let's get into it. So you're going to see me draw a literal diagram here. So if it says draw an airplane, I'm going to draw an airplane. So we have an airplane that sights a light raft. So you have this airplane kind of flying around, flying over water. Okay. And he spots a life raft. So I'm going to draw some water here. So water and a life raft. Okay, so life raft. Boom. Okay. So he sees it. He spots it. So what makes sense to me is that we have to draw what's called a sight line. So from the plane to the raft, we draw a line. Now we don't know how long this line is, but this represents what the pilot sees. So he's flying around, and suddenly he's kind of like looks down. Listen very carefully. He looks down and sees this raft. Okay. Now the other part is that the plane is flying at altitude, which means he is 5.5 miles off the water. And since an altitude is a height, it's taken at a direct 90-degree angle. And you can see right away we have this right triangle that's forming. This is good news because it makes it very familiar. Now, to solve this, we need an angle. Luckily, they do tell us that we have this 19-degree angle of depression. Now, here's what you're probably going to do that's going to be wrong. If you do get this wrong, I don't mean to be offensive to anybody. But there's a lot of people who are not going to be thinking very critically, and they're going to be putting 19 degrees right here. Let me tell you why that's super silly really fast, okay? If you put the angle 19 here, what you're saying to me is this guy, this pilot, is flying around looking straight down. I mean, literally, straight down through his aircraft. And then he happens to look up and he now sees the raft. That's not what's going on. That doesn't make any sense at all. Like, think about like when you've ridden around a car or you just walk around school. Do you stare straight down at your feet and then look up at people? No, that doesn't make any sense at all. Like, that's not what you're doing. So if you're doing that, please stop. Think more critically, because that's not at all what's going on. Okay. Let's talk about angle depression. Let's have a little mini discussion really fast about angle depression and how you actually take it. Now, first of all, you have to consider what's natural. And what's natural is that you always kind of look or start straight ahead. This is just like angle of elevation. Angle of elevation, you start by looking at the straight horizontal, then you look up because that's how people walk around. Like they look in front of them, or if you drive, you're looking in front of you. In this case, depression means you're going to be looking down. It's just the opposite of elevation. And so this angle that's formed by starting at the horizontal, and again, we're going to start right here, and then we're going to move and look down, hence depression. This is called the angle of elevation, or depression, excuse me, angle of depression. Oh, take a second to catch up. Sorry about that. So this angle, which I'm going to color in right now with green, that's the angle of depression. You always have to start at the horizontal and then move. So if we kind of zip back to our diagram, come on, computer, you can do it. All right, so zip back to our diagram. If we really want to take this angle of depression, we're going to have to start with a horizontal and then look down. That's 19 degrees. Now, you may say, well, oh no, that's not part of my diagram. That's not part of the triangle I'm trying to solve. But you have to use all your knowledge of triangles. So if this is horizontal, that means it's perpendicular to the bottom, which means that these are alternate interior angles, which gives this 19 degrees. Okay, so you have to remember what you know about triangles. Like we're building a year here, not a unit. So yeah, you do have to still remember all the stuff we did before. Excuse me. Okay, so let's continue on the story. So he now looks down, sees this raft, and he's like, "Oh, I need to maybe save this guy." So he starts to move. He starts to fly, but he's going to maintain altitude like a good pilot does, and he's gonna fly towards the raft. So at some point, he's going to make another spot check. I'm going to switch to blue here. So boom, blue. Okay. So he's going to do the spot check. So he has another sight line that's going to go to the raft. Now the raft isn't moving; it's just kind of bobbing there in the water. It's a terrible line. Let's try that again. That's not much better. There we go. Okay. And so he's looking down, this time at an angle of depression of 43 degrees. And again, this is 43, okay, which means this is 43. Okay. Um, and then he looks down at his pilot. Now he maintains his overall altitude, which means this distance has not changed, nor has the fact that his right angle changed. That's still 5.5 miles. Now the question here, I could ask a lot of different questions, but the question I'm asking you now is how far has this plane moved? So we have to kind of form a plan. I'm going to change to green here. So what I'm really interested in is this distance. Okay, and I'm going to call this distance D. Right. Now, you may be saying, well, this doesn't have anything to do with my triangles. It's like above my triangles. But again, you have to think about all the stuff we know about shapes. If D occurs there, D must also be here. So if you look at D there, this is similar to the previous problem. Looks like we're setting ourselves up for like a subtraction problem. So see if this fits with what you kind of are thinking. If we take the entire distance here, which I'm going to call A, and then I find the distance of this smaller triangle along the bottom, let's call it B. Hopefully you can agree that D should be the same thing as A minus B. So if I take the entire distance A of the red triangle, subtract out the distance B, I should get the distance D that I want, and that should be the same as whether I was traveling on the water or above it in the plane, since he's maintaining altitude and he's not like altering course or anything. So let's do it. We have to find two distances. So let's find the red one first. So we have room to do this. Let's do it below it. Okay. So let's solve for D. Now we're going through our same routine. So let's start with this. We know we're going to reference some kind of triangle, and that's going to be the same thing as the actual triangle that's in front of me that I'm trying to solve. We are going to need to pick a ratio and a reference angle. 19 seems to be good for me for the red triangle, for the big triangle. And we have to find the bottom. Now that's adjacent to 19. It looks like we have 5.5 to work with. That's the opposite. So it looks like I'm going to set up an opposite over adjacent for 19. The same thing as opposite over adjacent for 19. And then this step just sets you up for success. We want you to do it. The students who are performing really well on this, they're doing this. So if you find yourself having trouble and you're not doing these first two steps, you're not even helping yourself, man. So let's pull the actual triangle values. The opposite side is 5.5. The adjacent side I'm just going to call A. And now let's go to our trig sheet. And we need 19 degrees opposite over adjacent. So that's going to be the third column. 19 degrees is right here. Double check. 0.3443. Thank you, awesome trig sheet. You can go for now. So now it's just an issue of solving this algebraic problem. I'm going to cross multiply. I'm comfortable with that. So I'm going to put that over 1. And so cross multiply one way, I get 5.5. And that's A times 0.3443. Now this is just my normal algebraic solving routine. So 3443. And I'll probably have to go to my calculator for this one because I cannot do that in my head. So calculator, 5.5 divided by 0.3443 gives me an A value, which now this is the entire length, this is a big length, of 15.9744. Alright, now I'm not done here, of course. I need to find the small value, this distance from when he stopped. Oops, I'm sorry, I'm covering the whole thing. So I need to now find this distance B, the distance across the water from his second point of view. So for B, it seems like I'm going to find the same pieces, so I'll probably be able to just kind of reference my old work. I have my reference triangle, actual triangle. I want to find B, which is an adjacent. 5.5 is my opposite, so I'm going to go opposite over adjacent. Now my angle's changed. This is going to be for 43 degrees. Opposite over adjacent for 43 degrees. Now let's put in some pieces. So 5.5 over B. Opposite over B. Now let's find over A for 43. This should be right towards the bottom of my list. Third column over 43. I'm reading from the top. I know you can't see it anymore, but I'm reading from the top, so 0.9325. All right. So again, we're going to do some cross multiplying. So I'll stick that guy over 1. So 5.5 is equal to 0.9325 times b. So let's pull up our calculator again. I'll do this one off screen. So 5.5 divided by 0.9325 gives us a second distance of 5.8981. Okay, so I found the two distances. So basically the pilot starts 15.97 miles away from the raft. He flies, and he ends up 5.8981 miles from the raft. I want to know how far did he actually travel. Okay, so if we want to find the actual distance, we're going to take 15.97 9744. We're going to subtract off 5.8981. And again, I'll do this off screen. So let's see. 9744. And so that'll give a total distance traveled of about 10 miles, 10.0763 miles. Okay, there goes. So again, kind of review our work because ultimately this is the answer I'm looking for. So we first had to kind of come up with this really kind of accurate diagram, which means you have to know a lot of pieces, including angle of elevation, angle of depression. Once you have the diagram in place, we have to use our good problem solving skills to know the distance we actually want. We determined it's this value that's green D, which means I have to find the full red minus the blue to get green. We were able to do that, and it means the pilot traveled about 10 miles, all right? So that's problem 3. Now, guys, I'm going to give you inside word because if you're working this hard to watch this video to understand it, you should know that this is a really good problem. Hint, hint, nudge, nudge. Like, this is a really, really good problem. Like, I love this problem so much. Just please know what I'm trying to tell you here, okay? So this is part 3. I'll see you all in part 4.